Okay, so the screen is visible to all of you.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so we'll start our second module today, which is on kinematic analysis. Okay, so coming to the introduction part, say in case of cases like car wheels, in cases like car wheel, is a sphere rolling without slip on the ground. There is simultaneous motion motion of motion of rotation and just a second. Rotation and translation. Okay. For example, consider a link. Let's say we have one link A B. Okay. The link AB, let's say it is moved from its initial position to here. Now it comes to this position. Let's say point A is A dash now, point B is B dash now. Then it has been given a rotation. So to represent that rotation, let's say we'll represent like this. Now suppose point B dash is B1 now through this rotation. Okay, this is condition A. First there was a translation, then there was a rotation. In the second case, let's say the link is in this position. Let's say it is A. Okay, B. Then it has been given a rotation like this. Okay, rotation from AB to AB dash. Then we'll give a translation motion. So it will come here. So the final position is A1, B1. So when there is a simultaneous rotation and translation, it may be configured either in way A or in way B. Okay. First, there may be translation, then rotation, or there may be rotation, then afterward there may be translation. In actual practice, in actual practice, it is very difficult to separate these two motions. These two motions. Okay. So a combination of such motion is assumed to, sorry. So a combination of such motions is assumed to be rotation about some center I, okay, known as instantaneous center. Okay. Or we can say a virtual center of rotation. It is also known as virtual center of rotation. Now the instantaneous center, in short I will use the instantaneous center may be obtained from the intersection of bisectors of chords. This is O, huh? Chords A A1 and B B1. Okay. Now these right bisectors intersect at I, the instantaneous center, and it is called instantaneous center of rotation. Okay, it is called instantaneous center of rotation. Right. Now the locus of such instantaneous center is called is called centroid. Okay, centroid. Just a second. I'm receiving some important call. Give me 5 minutes. Hello. ସବୁ ପୁରା compulsory ଅଛି ଲେଖା ହେଇଛି ଇଏରେ ତମ ଫର୍ମ ତମର ନାଇଁ ସେଟା ଅଲରେଡି ଲେଖା ହେଇଛି ନହେଲେ ହବନି ନା। ସବୁ ଆଟେଣ୍ଡ କରିବାକୁ ହିଁ ପଡିବ ନହେଲେ ହବନି ଅଲରେଡି ଲେଖା ହେଇଛି ନା compulsory। ଠିକ ଅଛି ହେଲା। ହ୍ୟାଲୋ। ହଁ ପ୍ରବୀର ଏ ତମ ମେଲ କୁ ଆସିଥିବ ତମେ ଯୋଉଟା ମତେ ହ୍ୱାଟ୍ସଆପ କରିନଥିଲ ପିକେ ଜେନା ବିଏସଏସଟି ସେୟାର କରିଛି ତ ମୁଁ ଏଚଓଡିଙ୍କୁ ବି ପଠେଇଛି ସେ ପାଇଛନ୍ତି ଆଉ ଥରେ ଟିକେ ଚେକ୍ କର ତ ତମ ଡ୍ରାଇଭ କୁ ଯାଅ ନା ତମ ଡ୍ରାଇଭ ରେ ଦେଖ। ହଁ ହଁ ସେଠି ଆସୁନି କିଛି ମାନେ ଏଇ ପିଏଚଡି ଏଣ୍ଟ୍ରାନ୍ସ ଟେଷ୍ଟ ସ୍ପ୍ରିଙ୍ଗ 2022 ଆସୁଥିବ। ହଁ ଏଇଠି ଗୋଟେ ସେକେଣ୍ଡ ଆଉଥରେ ଆଚ୍ଛା ଆଉଥରେ ମେଲ ଆଇଡି ଟା କୁହ ତ ଟିକେ ପି ଜେନା bssut @gmail.com ଏଇଠି ଦେଖଉଛି ତ ହୁଁ ଏଇଠି ଦେଖୁଛି Mir Sutar HOD head underscore make goody 95 ଗୋଟେ ସେକେଣ୍ଡ ନହେଲେ ମୁଁ ଆର କପିଟା ଏରେ କପି କଲେ ହବନି ନା କୋଲାବରେଟର ନ କଲେ ହବନି। ତମର ମାଇ ଡ୍ରାଇଭ କୁ ଯାଅ ମାଇ ଡ୍ରାଇଭ ରେ ଷ୍ଟାର୍ଟିଂ ରେ ହିଁ ଆସୁଥିବ ଫାଷ୍ଟ ଯେହେତୁ ଏଟା ରିସେଣ୍ଟ ଟା ଉପରେ ଆସୁଥିବ ପିଏଚଡି ଏଣ୍ଟ୍ରାନ୍ସ ଟେଷ୍ଟ ସ୍ପ୍ରିଙ୍ଗ ପି ଜେନା ପି ଜେନା ବିଏସଏସଟି ନା ବିଏସଏସଟି ଆଚ୍ଛା ତମର ବିଏସଏସଟି ମେଲ ଆଇଡି କହିଲ ପିକେ ଜେନା underscore me @bssut.ac.in ଏଇଟା ଆଡ କରି ଦେଖିବା ଏଇଟା ଆଡ କରିଦବା ସେଇଟା ଦେଖ ତ ମୋର କ୍ଲାସ ବି ଚାଲିଛି ତ ହେଲା ସେମାନେ କେତେ ଜଣ ହଁ 6 ଜଣ ଯାକ କରିଦେଇଛନ୍ତି ତ ହଁ ପ୍ରଧାନ ସାଗରିକା ପ୍ରଧାନ ସମୀର ସାହୁ କିଶୋର ମେହର ସୁଧାଂଶୁ ସିଂ ନା 5 ଜଣ କରିଛନ୍ତି ଆଉ ଗୋଟେ ଫୋନ କରିଥିଲା ସେ କଣ କରିଛି ସବୁ କୋଶ୍ଚିନ୍ ଗୁଡାକୁ ଆଟେଣ୍ଡ କରିନି ଅଲ କୋଶ୍ଚିନ୍ କମ୍ପଲସରୀ ନା ନ କଲା ପର୍ଯ୍ୟନ୍ତ ଆସିବନି ନା ସେ ଏବେ ଜଷ୍ଟ ଫୋନ କରିଥିଲା ସବମିଟ ହେଇପାରିବନି ସବୁ କମ୍ପଲସରୀ ନା ଯେହେତୁ ଲେଖା ହେଇଛି କମ୍ପଲସରୀ ତେଣୁ ତାର ଜଣେ ଆଟେଣ୍ଡ ନ କଲେ କେମିତି ସବମିଟ କରିଦବ ହେଲା ତାକୁ ଦବା ଟିକେ 5 ମିନିଟ ସେ ଏବେ କରିବ ଆଉ କହିଲା ହଉ ସାର୍ ମୁଁ କରୁଛି ସାଙ୍ଗେ ସାଙ୍ଗେ 5 ଜଣ କରିଛନ୍ତି ସେ ଗୋଟେ ଝିଅ ଫୋନ କରିଥିଲା ସେ ଟିକେ ଟାଇମ ଦବ ଆଉ କଣ ନା ହଉ ହଉ ମୁଁ କ୍ଲାସ ସାରିକି ଫୋନ କରୁଛି I mean, how? Okay, is it visible to all of you?
Yes, sir.
Yes, sir. Okay, so actually, one test is going on in our department. In this regard, I got some call. Right. So these right bisectors when intersect at this instantaneous center, it is known as instantaneous center of rotation, and the locus of this instantaneous center is known as centroid. Means, if I draw, let's say we have this link AB, okay, and final position is suppose here. Let's say final position is here. It is A1, B1. Now our instantaneous center is somewhere here. Suppose, okay, here. Now the bisectors, if I join them, let's say this is one and this is another bisector. Okay, which are perpendicular to this, and this one is perpendicular to. Let's say this is point M, this is point N. Okay, so the locus is known as centroid. Okay, if you take at every instant, if you take the bisectors and join with them with the instantaneous center, and you will draw, then it is called centroid. Okay, then and you can write and perpendicular to the plane of perpendicular to the plane of motion plane of motion is called instantaneous axis. Okay, the locus of the instantaneous instantaneous axis is called axod. Okay, one is centered, another is axod. Means this straight line is known as centered, and the locus of this axis, okay, from B to B1 is known as axod. Okay, then other definition of this instantaneous center. Okay, the definition of instantaneous center. Uh, Consider a body P having a nonlinear motion. Let me draw first. Let's say we have two bodies. One is body Q, another is body P here. Okay, let me change the color. So let's say this is body Q, this is body P, and here we have 2 points. This is point A, and here let's say point B. Now velocity of point A is suppose V subscript A. Velocity of point B, okay, is let's say V subscript B with respect to this instantaneous center I. Now we'll join them, the points with the instantaneous centers. So this velocity should be right angle to the axis. Okay, this is right angle. Now consider a body, consider a body P is having non-linear motion, non-linear motion relative to body Q, okay, which is another body, and considering 2 points, considering 2 points, 2 points A and B, A and B in body P, the linear velocities of the linear velocities of A and B are BA and BB respectively. If a line is drawn, if a line is drawn perpendicular to BA at A and perpendicular to BB at point B, then their intersection, then their intersection intersection will give the instantaneous center. Instantaneous center. Am I clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir. In either way, we are telling if a body P is having some kind of nonlinear motion in relative to body Q, and you are considering 2 points A and B on that body P, which are having velocities BA and BB respectively, then we'll drop this axis AI and BI, which are perpendicular to their respective velocities. Then the two axes will meet at the instantaneous center. Means about this I, all the rotations are possible. Okay, assumed to be possible, right? So this is another definition of instantaneous center. Now, determination of velocity at a point. Determination of velocity at a point on a link. On a link. Okay. There are two important methods. Two important methods. First one is your instantaneous center method to find this velocity. Second method is relative velocity method. Relative velocity method. Okay. In this module, we'll concentrate on the displacement, velocity, and acceleration of link. Okay, that is why it is kinematics. Now, first method is your instantaneous method. Instantaneous method. So, instantaneous center method rather. Center method. Now, IC method, instantaneous center method for determining the velocity is based upon the concept that the concept that any any displacement of a body or a link having motion in one plane can be considered pure rotation pure rotation about some center about some center called instantaneous center. Now, what is that? Consider 2 points. Okay, sorry. Consider 2 points A and B, A and B on a rigid link Let VA and VB be the velocities of A and B respectively, whose directions are alpha and beta. Now, if you draw this, let's say I'll draw this. We have this link A and B. Okay. Now let's say point A is having a velocity VA in this fashion. Point B is having a velocity in this fashion VB. Now if you drop normals from these two velocities respectively, like this fashion, this is normal to VA and this is normal to VB, then they will meet at the instantaneous center. Now about their directions, if I say this is alpha, okay, and this angle is beta. Am I clear? Is it visible to all of you clearly?
Yes, sir.
Yes, sir.
Yes, sir. So what about this angle? It will be 90 minus
90 minus
alpha,
alpha.
and this angle will be 90 minus beta, right? So if it is V, then what will be this component? It will be VB cos beta. Okay, and what about this component of BA? It is VA cos alpha. Now, if VA, if VA is known in magnitude and direction, we know both its magnitude and direction, and VB is in direction only, then magnitude of VB can be determined by this instantaneous center method. Center method. Okay, by using following steps. Now, how to find? Now, first step is draw uh, draw AI and BI. Okay, perpendicular to the direction BA and BB respectively. Then let AI and BI intersect each other at point I. Okay, that is the instantaneous center. Then the complete rigid link to rotate about this I. Means how did we find this I? We know the magnitude and direction of this VA, but we know only the direction of this BB. Then we join these two axes which are perpendicular to their respective velocities, and they intersected at this point I, which is the instantaneous center. So the entire link AB will be now rotating about this I, assumed to be rotating. Okay. Now, since A and B, since A and B are the 2 points, are 2 points on a rigid link, on a rigid link, there cannot be any relative motion. There can't be any relative motion between them. Okay, along line AB. Now, resolving the velocities along AB, resolving the velocities along AB, we have VA cos alpha is equal to BB cos beta. This I have already shown to you. Or we can say that VA by BB is equal to cos beta by cos alpha, which is equal to sin 90 minus beta divided by sin 90 minus alpha. Let's say this is 1. Now applying Lamy's theorem, this AI by sin 90 minus beta, 90 minus beta is equal to BI by sin 90 minus alpha. Okay, from the geometry you can see. So it is AI by BI equal to sin 90 minus beta divided by sin 90 minus alpha. Let's say this is equation 2. Now from equation 1 and 2, from equation 1 and 2, it can be seen that this BA by BB is equal to AI by BI. Okay. Or we can say that BA by BB is equal to, sorry, BA by AI, okay, is equal to BB by BI. This way also we can express. Now what is this? VA by AI is equal to BB by BI. It is the angular velocity of the rigid link, that is equal to omega. This you might be knowing in your plus 2. This omega is your angular velocity of rigid link. Okay, and let's say this is equation 3. For any other point, let's say now we consider any other point C. Okay, so for any other point C on the link, C on the link will have BA by AI is equal to BP by BI equal to BC divided by CI. Okay, we'll follow this relation. So in this way we can find out the magnitude of any point on a link using Instantaneous Center method. Okay. Now number of instantaneous centers. Number of instantaneous center. Let your n is the number of instantaneous center, okay, in a mechanism and small n is number of links. In that case, our capital N number of instantaneous center will be equal to n into n minus 1 divided by 2. This is the formula you should remember. Okay. Using this we can find out. So I think I'll stop here. Tomorrow we'll proceed further about what are the types of instantaneous center, Kennedy's theorem, how to locate instantaneous center. All this we'll do. It will be very interesting. So tomorrow you be prepared with your pen, pencil, calculator, everything. Okay. As of now, it is clear to all of you.
Yes, sir.
Yes,
Oh,
sir.
Yes, sir.
okay then. Huh?
Yes, sir.
Just wait.
सर पीपीटी शेयर कर दो.
शूटिंग बंद कर दो.